Hello, class. So today we're going to be covering lesson number 5 on metamorphic rock. So let me just share my screen here. Maybe a bit challenging. My paws aren't very good at trying to navigate this keyboard. Here we go. Okay, so perfect. So looking at the notes here. So from last lesson, we looked at how metamorphic and igneous rock can become sedimentary rock. Today we're going to be looking at how igneous rock and sedimentary rock and even metamorphic rock can become metamorphic rock. So when I say metamorphic rock becoming metamorphic rock, what I'm talking about is having the rock break down and form into a new metamorphic rock. So what we touched on lesson number 3, where we introduced the 3 types of rocks. So metamorphic rock is when you have the rock change its structure from heat and pressure being applied to it. Sorry, I just had to get my glasses on here so I could read the text. So metamorphic rock, you need heat and pressure. So let's first look at heat, the first component we need for metamorphic rock. So heat comes from the heat that heats up the rocks comes from the Earth's core that heats up kind of all of Earth. All right, let's try this again. Okay, so let's start off by looking at heat. So on the left here, I have a diagram that shows the temperature of Earth at different depths from the Earth's crust. So on the top layer of Earth, or the surface of Earth's crust, we can average the temperature to be about 14 degrees Celsius. Some places it's a bit colder, some places it's a bit warmer, but on average it's about 14 degrees Celsius. We have a nice equation for the deeper we go into Earth's crust. For every kilometer we go down, the temperature is going to increase by 25 degrees Celsius. So that means once we get to 9 kilometers down, we get a total temperature of 239 degrees Celsius. When we get to 17 kilometers down, we have 439 degrees Celsius. And when we get to 25 kilometers down, Earth is at a temperature of 639 degrees Celsius, which is very hot. Your ovens would generally go to maybe 250 degrees Celsius at the hottest. So I went down to 25 degrees or 25 kilometers. That's what is thick on average as continental plates get. So once you get below the continental plate, there's actually a thin layer at the bottom of the lithosphere. There's actually still solid rock before we get to the mesosphere, where it's all molten liquid rock. Oceanic plates are a bit thinner, so they only go to about 9 kilometers, which means if you're on an oceanic plate near the bottom, the hottest you're going to get is about 240 degrees Celsius. Sometimes there's going to be spots that are a bit hotter. This is just kind of generally. So to produce metamorphic rock, we need to have a minimum heat of at least 200 degrees Celsius. If we don't meet this heat, we won't be able to produce metamorphic rock. And this temperature can change a little bit depends on how much pressure we have. If we have a lot of pressure, we don't need as much heat, but generally you need at least 200 degrees Celsius. And there's a diagram that I attach that shows the different types of metamorphic rock you can form and the different pressure and heat you need as well. But about the minimum, 200 degrees Celsius, and that corresponds to about 7.5 kilometers below Earth's surface, unless there's other things that are heating it, which we can talk about a bit more later. So there's a couple ways for rock to seep or move deeper into Earth's crust so it can reach these temperatures and form metamorphic rock. The first way to do it is through a subduction zone. That's when you have 2 plates coming together and one plate gets forced below. And as it gets forced into the mesosphere, that's when the temperature really picks up. So you can kind of move these rocks on the surface of that plate deeper into Earth's crust, and temperature is going to increase. So this is a quicker way to do it. A slower way is through just being buried. So as sediments pile up, the rocks that are below it are just going to get pushed down and down and down into Earth's crust. This can take millions of years, but over time, the rocks are just going to keep sinking and then rise up again, keep sinking and rise up again. It depends on how the plates move. So moving on from heat, let's look at pressure. Now, there's four main ways that pressure is going to increase or that we're going to have pressure on rocks. The first is maybe the most obvious. This is just when rocks get buried, you have more rocks on top. And those rocks on top are putting pressure. All their weight is on top of this bit of rock and it's putting pressure on it. So the pressure is going to build. So this kind of goes along directly with the buried. So generally, it's the sedimentary rocks that are getting buried, and those are the ones that are going to turn to metamorphic rock through this process of pressure from the rocks on top. Now, cause 2 and 3 have to do with plates colliding. So 2, we have plates colliding head-on, and these are what we call mountain building collisions. So those are gonna be like your reverse faults when plates come and hit directly. And as the plates hit, they cause a ton of pressure between the plates as they're pushing on each other. So that's when you get rocks, igneous, as well as sedimentary rocks, are going to form into metamorphic rock under this immense pressure and heat that builds as these two things collide. Third way is when you had a slip strike fault. This is when two plates are moving in opposite directions, and they build pressure as they slip by each other. So these aren't as common for building metamorphic rock, but they do happen. And when you had a head-on collision, that's the most common way that metamorphic rocks are formed. The fourth way, which is uncommon but can happen, is you get chemical reactions or water and gas gets trapped in Earth's crust and it heats up. As it heats up, it wants to expand and it's going to try to take up more space and put more pressure on the rocks surrounding that area. So to give you an idea of how much pressure we need, on Earth's surface, so like what we're walking around right now, we feel about 100,000 pascals, or 1 atmosphere pressure. That's from all the air that's on top of us. So all the atmosphere is pushing down on us. So that's where we get that 1 atmosphere pressure, which is what we're used to. The minimum pressure we need to form a metamorphic rock is about 300 million pascals, or 3,000 atmospheric pressures. So 3,000 times more pressure than we have on the surface of Earth, which is a lot of pressure. Humans, I don't know if I have a good estimate, but as we go deep into the ocean, we get more pressure from all that water that's on top of us, and that can actually crush us and destroy us. So if we're even close to this much pressure, we'd just be absolutely destroyed. We would be turned into metamorphic rock. So that wouldn't be great for us. Okay, so we looked at heat and pressure, but what do the heat and the pressure actually do to the rock? So first, rocks are made up of different compounds, which are made up of atoms. So you have a bunch of atoms, and they're just arranged, depends on the rock, they can be arranged randomly, but they're pretty tight and close to each other. When the rocks are heated and put under a ton of pressure, these atoms are going to rearrange. So you're going to change how they fit with each other, and they're going to form tighter bonds. So this is why your metamorphic rocks are generally the hardest rocks, because these atoms form stronger structures. And the rearrangement of these atoms can drastically change pretty much every property about the rock. So one example of this, even though it's not a rock, but just maybe a common one that you can think about, is diamonds. So coal and diamonds are the same thing. They're both made out of just carbon. They're pure. So you get just carbon, and coal, it's like black, it's ugly. The only use of it is like burning it. Well, it's probably other uses, but the main use I know of is burning it. Where diamonds, they're beautiful, worth a ton of money, and all it is the atoms change their alignment. So when coal is put under a ton of heat and pressure, it changes, the atoms change their alignment, and they form a nicer structure that actually changes the way the diamond looks, the strength of the diamond. Pretty much every property about coal changes when it becomes a diamond. Okay, a couple of side notes I want to touch on. So when we talk about adding heat, if we add too much heat to the rock, we're just going to melt it, and that's going to form magma, which is going to start the rock cycle all over again. So it's not helpful if we put too much heat in when if we're trying to make metamorphic rock. If we put too much heat, we just get magma, and we can't get a metamorphic rock. So the heat has to be between probably about 200 degrees Celsius and 800 degrees Celsius, give or take, depends on the rock. Secondly, rocks can become metamorphic rocks really quickly, pretty much instantaneously when plates collide, when you get a ton of pressure really quick and heat, or it can take millions of years. So this is when the rocks become buried, and it takes a while to get these metamorphic rocks. So it depends on how they're formed. It can be really quick or really slow. Okay, so that's the end of the lesson for today. I have problems in your classroom for you to answer. Have a good rest of the day.